The transceiver was connected to the antenna for communication in the VHF frequency range. We could have done this before connecting the transceiver to the power supply. Now we will connect the station to the GPS antenna so that the transceiver receives information about its precise position. For that we need a cable that has a cinch connector on one end and a more pin connector on the other. The compatible connector is found on the back of the transceiver and is very easy to recognize. Both connectors are cylindrical and have one flat surface. When connecting the connectors, the flat surfaces of the two connectors must be at the same level. On flat surfaces, there is also an arrow indicating the direction of connection. Then connect the cinch connector to one of the two connection points offered. To see that the GPS system is activated, it can be checked on the GPS setup interface and turn on the GPS source. As a GPS source, the transceiver should recognize NMEA 0183. In the settings for the number of symbols per second, NMEA 0183 baud 4800 should be registered. The transceiver is still in the mode of searching for its position in the GPS system because the antenna is not yet connected to the power supply. When the antenna is connected to the power supply and the positioning is completed, the precise coordinates of the transceiver will be shown on the display. We supply the GPS antenna with a DC voltage source of 12 volts. The antenna began to draw a very small current of 0.04 amps. When the transceiver receives information about the position via the GPS antenna, this information will be displayed on the monitor. It is very important that the station must not transmit with a power higher than 1 watt, so it is necessary to set a limit on the current that can flow to the transceiver on the DC source. The source is adjusted according to the existing markings on the button so that it cannot provide a current stronger than 1.5 amps. Thus, a transceiver with limited current strength will be able to transmit with a maximum of 2 watts. Position information has been received and is on the monitor. It is necessary to select the low option on the microphone so that the transceiver transmits with a power of 1 watt. When low is clicked, all channels are in 1 watt signal transmission mode. It may happen that by switching to another channel, the transceiver can switch to high mode by itself. Therefore, it is always necessary to check whether the transmission power is 1 watt on the screen before transmitting. If you forget to set the transmission power to 1 watt and the current limit is not set, the fuse placed in the power cable will melt. Now that the transmit power and current limit are set, we can start transmitting on channel 9. The transceiver draws a current of 0.99 amps. Now we change the transmit power to 25 watts, and we see that the current is limited. Where the voltage has dropped to a value of 4.7 volts. And the transceiver cannot transmit with a power stronger than 1 watt. If the current is not limited to the power supply, the fuse will blow. Channels can also be changed on the microphone unit. The power can also be changed via the touchscreen. The transmission power on the 17th channel is always limited to 1 watt. Switch the transceiver to the 18th channel and change the transmission power on the touchscreen.